Question 2. A student investigated the time taken to collect 40 cm³ of hydrogen gas. Let's underline that. 40 cm³ of hydrogen gas when magnesium reacts with dilute sulfuric acid. Investigated the time. So it's more or less like rate of reaction kind of thing here. So 5 experiments were done using the apparatus shown. We have dilute sulfuric acid and distilled water, inverted 50 cm³ measuring cylinder water. Okay, now using a measuring cylinder, a cm³ of dilute sulfuric acid was poured into the boiling tube using a second measuring cylinder. Let's underline the 8 cm³ of dilute sulfuric acid, and what was used here, a measuring cylinder. Okay, using a second measuring cylinder, 12 cm³ of distilled water was added to the acid in the boiling tube. The apparatus was set up in the diagram ensuring the inverted measuring cylinder was full of water, okay, to ensure that there is no space or there's no air in between and inside the cylinder. The bung was removed from the boiling tube. A coil of magnesium, a coiled length of magnesium ribbon was added to the boiling tube. The bung was immediately replaced and a timer started. The time taken for 40 cm³ of gas to be collected was measured. The student felt the outside of the boiling tube. The student felt the outside of the boiling tube. Okay. The student noticed that the boiling tube was warm. What does this tell you about the type of reaction? Now, for the boiling tube to be warm, it means that the final temperature is greater than the initial temperature. And for the final temperature to be greater than the initial temperature, it means that the enthalpy heat is given off to the surrounding. It is given off by the system to the surrounding, and a process or a reaction in which it is given off by the system to the surrounding is known as an exothermic reaction. Okay. Describe one change that could be made to the apparatus to help keep the temperature of the contents of the boiling tube constant during the reaction. Okay, as you can see here, you could see that the heat was being lost to the surrounding. So it means that over a period of time, the temperature will not be constant, but to keep the temperature constant, we need to carry out this experiment at a constant temperature. Then something must be done to this setup. And what is that? We need to put this setup. This setup needs to be placed in a water bath. We need to place this setup in a water bath. The water bath will help regulate the temperature of the water, help make it constant. So by placing the boiling tube or the reaction vessel in a water bath. Okay, then the boiling tube was rinsed with distilled water. Experiment 1 was repeated using 10 cm³ of dilute sulfuric acid and 10 cm³ of distilled water. Now go back to experiment 1. What do you notice? 8 cm³ of sulfuric acid was used and 12 cm³ of water was used. Okay. Now in the second experiment, 10 cm³ of dilute sulfuric acid and 10 cm³ of distilled water. So have you seen a trend there? What kind of trend do you see? 8 plus 12 gives us 20, right? Okay. 10 plus 10 gives us 20. Fine. Experiment 3. Experiment 2 was repeated using 12 cm³ of dilute sulfuric acid and 8 cm³. So 12 plus 8, 20. Experiment 4, 16 plus 4, 20. As the volume of sulfuric acid increased, dilute sulfuric acid increased, the volume of water decreased. So onto experiment 5, 20 cm³ of dilute sulfuric acid and no distilled water. Alright, so now use the information in the description of the experiment and the timer diagrams to complete the table. Record the time in seconds. Very key. That's the instruction. Record the time in seconds. So fine. Here now, since we know the total volume of the sulfuric acid solution and water must be 20 cm cube. So here sulfuric acid is 12. Here this one water will be what? Sorry, sulfuric acid is 8. Water will be what? 12. Whereas here 10. So water will be what? 10. 10 plus 10, 20. 3. 12 plus 8. 12 plus 8 will be 20. 4. 16 plus 4 will be what? 20. So 5 is 20. That will be 20 plus 0 will give us 20. Alright. So now our time to collect 40 cm cube of gas in seconds. Now we have two dials here. The inner dial is in minutes, while the outer dial is in what? Seconds. And in each dial we have 5, 10, 15, 20. You have 20 divisions in the inner dial, right? That's 20, representing 20 minutes, because each division is 1 minute, right? Or 60, like call it 60 seconds, right? Whereas in the outer dial here we have 0, 15, 30, 45, 60. We have 60 seconds in the outer dial, right? Fine. So whatever we get from the inner dial, we'll add it to the outer dial. Whatever I get from the inner dial, we convert it to seconds and add it to the outer dial, and then get our final answer. Alright, so let's start. So this is 0, so this is 1. 1, 2, 3, 4, 5. Good. So this is 1. That's 1 minute plus the seconds. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 minute plus 12 what? Seconds. 1 minute is how many seconds? That's 60 seconds. 60 plus 12, that gives us what? 72 seconds. Okay. This is 0 minute. 0 minute plus outer dial 45 seconds. 45 seconds. Okay, so that gives us 45 seconds. Next, 0 minute. 0 minute plus that's 30, 31, 32, 33. 33 seconds. That gives us 33 seconds. You don't need to write this in your answer book. You can just write it somewhere in a rough sheet or somewhere if there's any, or you can just put it down somewhere on a sheet on your question paper, or probably by the side here. That will be okay. Then there's the same thing here. 0 minutes plus 15. This is 20, 21, 22, 23. 23 seconds, right? So that will be 23 seconds. That will be 23 seconds. And the last one, 0 minutes. 0 minutes and 16 seconds. Gives us 16 seconds. Okay, you don't need to write the seconds here because already given up there. So let's erase this. Okay. Alright, so with this now, can you see the trend? As the volume of, what do you notice here? As the volume of the acid increased, what happened to the time? The time decreased. The time of reaction, or time taken to do what, to collect the gas, decrease, right? And when you have volume of acid and water changing, as the volume of acid is increasing, the volume of water is as the volume of acid is increasing, the volume of water is decreasing. What do you think is happening to the concentration? The concentration of the acid is what? Increasing. The concentration of the acid will increase, which means that as the concentration of the acid increases, what will happen to the rate of reaction? The rate of reaction will also do what? Increase, because it will take a shorter time for the reaction to do what? Occur. So that's why we have a decreasing what? Time to collect the 40 cm cube of what? Of the gas. So let me write the equation of reaction here. Whenever you have a question like this, don't always forget to first of all write the equation of reaction to guide you. Magnesium plus H2SO4 gives us magnesium tetrasulfate 6 and what? Hydrogen what? Gas. So displacement reaction. Fine. Okay, so let's move on to the next question. Now add a suitable scale to the y-axis and plot the results from experiment 1 to 5 on the grid. Draw a smooth line graph. Draw a smooth line graph. When you are told to draw a smooth line graph, directly they are trying to tell you to draw what? A curve, because it can mean that you can use your free hand to draw a smooth curve, or you use a French curve, draw your what? Your curve. Right now, okay, from our table, the maximum value here is 72, while the minimum value here was 16. All right, so let's come here. So how many major boxes do we have? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we make these 20, 40, 60, 80. Now whatever scale you are choosing, it must be a scale that will cover at least 3/4 of your what? Of your graph sheet. Fine. So we can make this 20. We can make this 20. We can make this 40. We can make this 60. We must use a scale that you can easily read off. You can make this 80. That this will be what? 100. Yeah, this will be 100. While this will be 0 on the y-axis. So what's the scale on the y-axis? So y-axis, you see 2 cm equals to 20 seconds. Yeah, that would be good. So from our table, when you are plotting the volume of dilute acid with what? Time, right? So when the time is 72, the volume is what? 8 cm cubed. All right. So from our graph, when the time is 72, where is 72 here? If this is 60, 61, 62, 64, 66. Remember, if 10 small divisions make up 20, means that one small division will be what? 20 divided by what? 10, which is what? 2, right? Fine. So if this is 60, this will be 62, 64, 66, 68, 70, 72. So 72 will be somewhere here, right? So 72, somewhere here. Then 8, where is 8? All right. So 8 is the next grid here. So mark this, then mark it with a cross, small cross, star cross, or you can use a small dot with a circle around it, right? Okay, that's the first point. The second one, when the volume is 10, the time is 45. The volume is 10, then 42, 44, 45 should be somewhere here. 45. Okay, the next one, when the volume is 12, the time is 33. When the volume is 12, time is 33. Okay, so this is 12, 22, 24, 26, 28, 30, 32. So 33 should be somewhere here. 33 should be in between 32 and 34. So that will be, put that dot here, right? You must plot your points correctly. Okay. Then next point, when volume of acid is 16, experiment 4, time is 23. Volume of acid is 16, time is 23. So 20, 22, 23 should be somewhere here and somewhere here, right? So we come here. All right. Then lastly, when the volume is 20, time is 16. When the volume is 20, volume of acid is 20, time is 16. This is 2, 4, 6, 8, 10, 12, 14, 16. So somewhere here. All right, this point here, so we can mark our point there. Excellent. So what then do we do? So you can see at this point, well, it may be a bit difficult for us to join all the point bets. So with your curve, that's why you need a curve for this. Alright, something like that. With your curve, it will be smoother than this, right? Fine. Okay, let's see. From your graph, deduce the time taken to collect 40 cm cube of gas if the experiment was repeated using 9 cm cube of sulfuric acid. 9 cm cube. Where will, if this is 8, this is 10. So 9 cm cube will be in between what, 8 and 10. Or for sulfuric acid. So 8, you can see in this x-axis what happened here. 2 cm cube represents what? 2 units, right? 2 cm cube represents 2 units, 2 cm cube. Means that one division will represent 0.2. Because there are 10 small divisions here representing 2 cm cube. So one division will be 0.2, right? Fine. So what do we do? So this 8, 8.2, 8.4, 8.6, 8.8, 9. Good. This is 9. This is 9.2, 9.4, 9.6, 9.8, 10. Fine. So these are our 9. Let's just write it down. 9. So with a ruler, you trace this point up. Mine may not be too perfect. But with your ruler, do this with your ruler, you trace it up to this point and then trace it down. Trace it down to the y-axis. If possible, indicate with a what? An arrow. So what point is that? That is this is 40, 42, 44, 46, 48, 50, 52, 54, 54. So show clearly on the grid how you worked out your answer. So this is 54 seconds. That's 54 seconds. And the 2 marks here are distributed as thus. 1 mark is for the value that you've read off from your graph, and 2, the second mark is for the workings that you have shown, the traces you have done with broken lines, right? Fine. So what volume of distilled water would be needed if the experiment was repeated using 9 cm cube of dilute sulfuric acid? Remember I said the volume of acid plus volume of water gives us what? 20 cm cube, right? So if the volume of acid is 19 cm cube, what would be the volume of water? Of course, 11 cm cube. Now at times they may not give you the unit here, and if you are not given the unit, then this mark will be what? 3. So 1 mark will be for the unit based on the axis of where you're reading your answers from. While 1 mark will be for the unit, 1 mark will be for the answer itself, while the last mark will be for the trace shown on the graph. Right. The rate of reaction can be calculated using the equation shown. Rate of reaction equals the volume of gas collected divided by time taken to collect the gas. Use this equation to calculate the rate of reaction in experiment 1. Give the units for the rate of reaction you have calculated. What is the volume in experiment 1? Volume collected is 40 cm cube, okay? Then the time taken is what? 72 seconds, okay? So volume of gas collected, that is 40 over what? 72. That will give us 0.56. Now what will be the unit? The volume of gas collected is what? Cm cube, while the time taken to collect the gas into what? Seconds. So the unit is in what? Cm cube per second. And you get your cheap 2 marks. In which experiment 1, 2, 3, 4, and 5 was the rate of reaction greatest? Of course, the rate of reaction will be greatest in the experiment that took what? The shortest what? Time, right? And what's that? That's experiment what? 5, because our time of reaction decreased as the concentration of the acid increased, or as the order of experiment increased. So the shortest time is what? 16. That's experiment 5. Why would measuring the volume of dilute sulfuric acid with a burette rather than a measuring cylinder be an improvement? Remember having told you to underline certain words when we're reading through the analysis, right? Measuring cylinder, yes. Whenever you see questions like this, always expect a question on the disadvantage of using measuring cylinder to measure the volume of whatever solution or liquid we're measuring with, right? Because there will always be a comparison between using a measuring cylinder and using either a pipette or burette to measure that same word substance, right? So let's go back to that question. So why will it be better to use what? A burette rather than using what? A measuring what? Cylinder. A burette gives what? A more accurate what? Measurement. The burette and pipette always give more accurate what? Measurement than the measuring cylinder because of their smaller what? Radii. Because of their smaller radii or diameter, right? So the smaller the radius or the smaller the diameter, the smaller the error margin. But the wider the diameter or the wider the radius, the wider the error margin. But the advantage that measuring cylinder has over burette and pipette is that it is what? Faster to use. It's faster to use a measuring cylinder to measure any volume than using burette and what? Pipette. Burette and pipette take time, right, to use. Then for burette and pipette, when you want to measure an exact or fixed volume of a solution, the best apparatus or piece of apparatus to use is your pipette, not your burette, because a pipette has only one volume. A pipette can only measure only one volume at a time. Only one volume. It's calibrated to measure only one volume of a solution or liquid at a time. Alright, so let's continue. The magnesium starts to react with the dilute sulfuric acid as soon as it is added. Why does this decrease the accuracy of the investigation? Yes, because immediately you add, got this? Yes, because immediately you add the magnesium to the acid before you cover the bomb, the reaction will start. Because it's a spontaneous reaction, right? It's a spontaneous. Immediately the magnesium touches the acid, hydrogen gas will be what? Liberated, and that volume will not be accounted for. That volume will not be measured. So at the end of the day, whatsoever you are measuring will not be accurate, right? So that is why that decreases what? The accuracy of the what? Investigation. The hydrogen gas escapes before the boiling tube. Is covered with the bomb. So describe one improvement that you can make to overcome this problem. Now, one improvement that can be made to overcome this problem is an improvement that will eliminate the escape of what? Of the hydrogen gas before the bomb is covered. So what can we do? Now look at this. If we tie the magnesium ribbon to this bomb with a thread outside, right, and then drop it, tie the magnesium ribbon to the thread so that as we are dropping inside the boiling tube, right, as it's touching the acid, the bomb is also covering or corking the boiling tube, so there will be no way for the gas to escape. By so doing, we will get a more reliable result. So what are we to write here? By tying what? By tying the magnesium ribbon to a thread and the thread tied to the bomb.